So Michelson-Morley experiment. So it is the famous experiment which disapproves the ether hypothesis given by Huygens in 1678, and this experiment was performed by A. Michelson first independently in 1881, and then in collaboration with E.W. Morley in 1887 at Cleveland. This experiment laid foundation of the theory of relativity. So what is the working principle? Working principle that I have explained in my previous video. So in which we have to send two light signals. So one is in the direction of the propagation of Earth with respect to ether, if ether exists, and it is at rest, and Earth is moving with respect to ether. So the in which Earth is moving, and that direction is considered as the longitudinal direction, and in the light signal is sent in that direction, and it is reflected back from the mirror, plane mirror, and it come back to the starting position. Similarly, from the same point in the transfer directions, the light signal is sent and returned back from by the plane mirror M1. So if T1 and T2 are the time taken by the light to come back to the starting position, if T1 is equal to T2, then there is no ether, or if T1 is not equal to T2, then there is the question that ether can exist. So the working principle. So and this concept is used, and the more interesting thing that is used in this experiment is that it has been established that Earth is moving around the sun with the linear speed, that is 30 kilometer per second. So that is very, very high. So that is why they use the light speed of light is very approximately 10,000 times the speed of sound. No, not speed of Earth. So experiment arrangement. So they used a monochromatic source of light, point source, that is a sodium lamp. Its wavelength is 5893 angstrom, average wavelength. So 5893 angstrom, and it is converted into the parallel beam using a convex lens, and there is a semi-silvered plate on which when the light falls, and from that the second side light is divided into two rays. One is the reflected 50% approximately. So this is semi-silvered glass plate. So 50% of the light is reflected and 50% of the light is transmitted, and the reflected light when strike the mirror M1 plane mirror, it returned back. Similarly, the transmitted light ray when strike the mirror M2 and plane mirror reflects the incident ray in the backward direction. So after joining with a plate P, they reflected the downward direction where a telescope is placed. It can detect the interference pattern of the two rays. In this case, there is another plate, that is Q. This plate is a transparent plate, and it is made up of same material from which this plate P is made up of, but it is only transparent, but not like that the P which is semi-silver. So the basic aim to introduce this plate Q here is to compensate extra path difference gained by the reflected light which passes through this plate twice, but the reflected light only passes one. So that is why this plate is termed as compensating plate. Plane mirror M1 and M2 are placed at the same distance, small d, from this point plate P. So the interference pattern results in the alternate dark and bright bands, which are called fringes. So the whole apparatus, is was mounted on a firm rock, and the firm rock is placed in a big trough, and that trough is filled with mercury, and at the same time this rock is in continuous rotation with 1/6 revolutions per minute, that is 60 degree per minute. So in one revolution, that is one revolution in 6 minutes. So this value of d used by Michelson and Morley experiment is approximately 11 meter. So theoretical calculations involve that first we observe these fringes these fringes in first position, in which the source is placed here and telescope is there, and after 90-degree rotation, again clockwise rotation, and the telescope comes to this point, and this case again the fringe pattern has been observed. And if the pattern and there is any change in the pattern or any shift in the fringe, then it is noted, and that fringe shift can be used to detect the existence of ether. The mathematical part is very simple. In this case, suppose the source and this plate P, and when the light strikes here and it is reflected, for the time the light ray reaches to the mirror M1, as Earth is moving in the longitudinal direction, so that means this velocity is very high, that is 30 km per second. So in that time, this mirror M1 changes slightly to this position, and the light ray reaches the mirror M1 dash. Okay, and the distance, this distance is equal to, suppose total time taken by the light going in this direction and come back to the plate P is t1, then the time taken by the light ray reaching from P to M1 dash is t1 by 2, and c is the speed of light, so that is why this distance is equal to c t1 by t2. Okay, when when it is reflected back, and again the same concept is used, and this plate P covers the distance, this distance approximately twice this distance, and it reaches to the point P dash, and mirror, which is in the longitudinal direction, that is M2, again moves further. So calculation of T1 using the right angle triangle P, M1, M1 dash, and using Pythagoras principle, so it can be easily calculated that this concept, that is mm dash, is equal to, again time same, so this speed is v, then v into t1 by 2. So putting these values in these replacing these pm1 dash by the values, and rearranging and using binomial theorem, we get this time t1 is equal to 2d by c into 1 plus 1 by 2 v square by c square. So similarly, calculation of t2 according to classical velocity addition theorem. So t2 is time taken by the light ray reaching the mirror m2 and come back to the m2 dash to m2, and that is calculated, and d by c minus v plus d upon c plus v, that is 2d by c plus 1 minus v square by c square. So this is termed as equation number 3. Using equation number 2 and equation number 3, we can judge delta t, the difference in t2 minus t1, and delta t comes out to be dv square by c cube. That is termed as equation number 4. So path difference corresponding to the time difference can be calculated by multiplying the time difference with the speed of light. That is, it comes out to be, path difference comes out to be dv square by c square, termed as equation number 5. If the path difference is equal to the wavelength of the light, that is lambda, then the number of fringe shifts is equal to 1. Therefore, fringe shift in this case, that is delta n, that is equal to total path difference divided by the wavelength. So it is equal to dv square by c square into lambda, that is termed as equation number 6. Now, due to the rotation of 90 degree, and in this case t1 converts into t2 and t2 converts into t1, so that is why the path difference is equal to 2 into delta x. So twice the path difference. As a result, the fringe shift is twice, so it becomes to be 2 dv square by c square into lambda. This is the final expression for the change in the fringe shift by the 90 degree rotation. So putting the value of small d 11 meter v square by c square is equal to 10 to the power minus 4, and wavelength of light of sodium, that is average value 5893 times 1 minus 10 meter. So this delta n comes out to be 0.37. Theoretically, there should be a fringe shift of fringe shift if ether exists. If ether, or in other words, if ether exists, the fringe shift should be observed. So experimentally. So this is a theoretical concept. Now, if and experimentally, what did Michelson Morley experiment concludes? So they observed no such fringe shift, and with the apparatus having accuracy of the least count of 0.01 fringe shift, so that means the apparatus which can detect even 0.01 fringe shift, they didn't detect any fringe shift. So negative result of Michelson-Morley experiment were a big blow to the ether hypothesis. So it is concluded that the absolute motion of the frame of reference in ether cannot be detected. So in other words, ether does not exist. So that's all.